Video on combining like terms.
It's Mario.
Hold on.
That's me.
This ain't no NBA young boy.
Kevin Durant is trash. He's washed.
Bro!
Letting you know all your comments are getting on video. It's recording right now.
In this tutorial, we're talking about combining like terms. And in the intro, we learned that like terms are terms that have the same variable and the same power, the same exponent. And we saw a couple real-life examples. We saw a Mario Kart game and a basketball game. And in the videos, I asked who is on the same team. Well, let's take a look at a picture here. We have a picture of a basketball game. Who would you say is on the same team here? I'm going to go ahead and highlight some guys that I see that are on the same team. The guys in the white jerseys are on the same team. How did I know that? They're wearing the same jerseys. That's how we tell a teammate. Well, combining like terms is basically the same thing. They have the same jersey or a look. Let's take a look at an algebra example. We have the example 4x plus 3y minus 2x. Part X is on the same team. Who would you say? Yeah, that's right. 4x and minus 2x would be on the same team because they have the same letter or the same jersey, whatever you want to call it. They look the same. We're going to combine those. Here's the part. When you're combining like terms, all you're worrying about is the big number in front. It's called a coefficient. Here the coefficients are 4 and minus 2 or negative 2. We're only going to combine those numbers. We don't worry about the letters. That's just the jersey. You don't need to do it with it right now. So we're going to do 4 minus 2 because there's that minus in front, which is 2. And then you leave the jersey on because you play with a shirt. 4 minus 2 is 2, which will leave you with 2x. And we're left with 2x plus 3y. And our final check is to see if there's any more teammates after we simplify. Are there any more?
Yeah.
No, because they don't have the same letter. We're good. We can't do anything else. Let's take a look at another example. We have 7 plus 2xy plus 5xy minus 3. Once again, who's on the same team? Right away, I see that 2xy and 5xy look exactly the same. They have the same jersey, the same letters. Those are teammates. We're going to add those up because there's a plus sign in the middle. 2 plus 5 is 7. We have 7xy. Let's go and rewrite this. We got 7 plus 7xy minus 3. Looks like we're done, right? Wrong. We got one more step. There's another set of teammates here. If you might have noticed, the 7 and the minus 3 are teammates.
What are they
You
called?
might be saying, well, they don't have any letters. They don't have a jersey.
Nonsense, go.
So how can they be teammates? Well, that's a good question. If you have just straight up numbers, we call those constants. And if there's just two constants with no letters next to them, those are teammates because they look very similar. They both don't have a letter. We're going to combine those. We have 7 minus 3, which is 4. We're left with 4 plus 7xy as our final answer. One last example. We have 5x squared plus 3x minus x squared. This one's a little tricky too, because right off the bat, it looks like they're all teammates because they all have the same letter, right? Well, there's one other thing that we learned in the intro. In order to be teammates or like terms, they not only have to have the same letter, but they also have to have the same exponent. The only two terms that have the same letter and exponent here are 5x squared and that minus x squared. Those are our only teammates. We got to combine those. 5x squared minus x squared looks a little tricky, but whenever there's just a minus x squared, we know we can put a 1 in front there because it's just an invisible number. 5x squared minus 1x squared is 4x squared. We're left with 4x squared plus 3x. That's as far as we can go. We're done. That's combining like terms.
All right. So, we are here. Open up your notes from yesterday. Let's review things from yesterday. What is a variable? It's a letter. A variable is a letter. What is a constant? And constant is just a number. What is a coefficient? A number in front of a variable. What is a term?
Cool.
What is a term? Guys, if I were you, I'd go back up to the top where I have all of these definitions. What's a term, Braylon?
Number or a variable?
Yeah, you can have a constant can be a term, and anything that has a variable. Okay, coefficient variable can also be a term. Separated by plus signs and minus signs. All right. So, we ended yesterday with writing down like terms, right? We did that on number 4. So now we have simplifying expressions right here. Everybody ready? You with me?
Yes.
All right. It says we can simplify algebraic expressions by combining like terms. Once you have that written, get a highlighter and highlight combining like terms. All right, you will hear me saying combining like terms often. I will not write combining like terms. What I will write will be I'm on the highlighter. Will be CLT. What is that going to stand for? Combining like terms. All right, it says be careful when you are combining terms to check the operation that is in front of the term. All right, so we're going to look at this example here. We're only going to do part B. We're going to skip a few steps and just do part B. All right? It says the Robinson family ordered snacks at the state fair. They bought the following drinks, and we're going to use what variable? D. They also bought pizza, what variable? And ice cream cones, what variable? C. So we have pictures of what they bought down below. On A, if we were doing that one, we would write each individual variable. So I would write P for what? Pizza plus another P plus D plus D. Are y'all seeing me? Here, look. We would write P plus D plus D plus C plus B. Are y'all seeing that? Now, you most of the time don't want to write it out like that because it would take a lot of your room. Do you agree? So this is where your combining like terms helps. Look up at my pictures. How many pizza slices do you see? There's 5. So how could I write that? 5 P's for 5 pizzas. So then, how many drinks do you see? 3. So how would I write if I have 3 drinks? 3 plus 3D. And then I need to look at my ice cream cones. What would I write there? 2C. Now, at this point, how many different items do I have listed up there? 3. Do you agree? How many terms do I have listed on B? I have 3. Do you agree? I have a 5P, a 3D, and a 2C. I cannot combine it anymore. Because I have 3 items and I now have 3 terms, that is as simplified as I can get it. Can somebody tell me why I cannot add these 3 terms together? They're not the same. They're not alike. They don't have the same variable. Awesome. So that would be your answer. This is what we're practicing today. Okay? Knowing when we can combine things and when we cannot. So this first example here, they already did it for you. Do you see how they did squares and circles? We have an upper hand on them because we have a tool that does different colors. So instead of different shapes, we're going to do different colors. So I'm going to choose blue, and I'm going to highlight all the terms that have a B, blue. And then I'm going to highlight all the terms that are constants, red. So again, I'm not going to do shapes, I'm going to do colors. Your colors can be just like mine, or you can choose different colors. I don't care. As long as the pattern is the same. So at this point, how many different colors do I have there?
2.
I have a blue and a red. Do y'all agree? Which means I have to simplify this expression to 2 terms. So I can combine the blues together. When you start your combining process, you have to look at the coefficients. What is a coefficient? Number before a variable. So on my blue terms, I have a 14, and then I have a plus 6. Y'all see that? So I would do 14 plus 6, which equals, as this one's done for you, look up there. What is 14 plus 6? 20, and I keep the variable. So then I do the same thing for my constants. I have a positive 8, but then I have a what? Negative 12. So what is 8 minus 12? Negative 4. So here it is, negative 4. I have 2 different colors. Do I now have 2 terms? Yes, I'm done. I cannot combine that anymore. All right, so when you start your combining process, you don't look at the variables anymore. The variables are used for the highlighting. Do y'all agree? Once you've already highlighted, when you start combining, you look at the coefficients. All right, so let's look at the second one. I'm just going to choose blue to start off. I'm going to highlight all my terms that have a J, blue. You done? All right, do I have any more terms that have the variable J?
Yes.
Which one?
6, 7, and 5.
Now remember, when you're highlighting, you have to include the operation before it with it. So this needs to be a plus 6.7J. Any more?
Negative 5.
And then the negative 5J. Are there any more now?
No.
So now I need to change colors. And I have a, what is this number called? A number all by itself is called a constant. How many different colors do I have up there? 2. Which means after I start my combining, I should have 2 terms. So, what do I combine together now? All the terms I have highlighted blue. Do y'all agree? Get your calculator. You're going to do 4.2 plus 6.7, and then what? Minus 5. 4.2 plus 6.7 minus 5. Olivia, what'd you get? 5.9, and I have to keep the what? The variable J. Good. So there's one of my terms. My second one, though, that negative 5. Do I have any other green ones?
No.
That's the only one I have. So if that's ever the case, you just keep that term. Just bring it straight down like it is. So I put minus 5. So this was my combining like terms that had the variable J. And this one was my constants. Do I have 2 terms? Can I combine them together? Because one has the variable J and the other one does not. I am finished. Okay? I want you to try the next one on your own. Try the next one on your own. I'm going to give you like a minute. I want to see what you can do. Start your combining. So with the highlighting, I'm going to just start by choosing a highlighter. So I'm going to choose this one is going to be my C terms. And I have another C term.
Yes.
What I'm seeing people do is this. Somebody tell me why I don't need to do this.
Because you're not highlighting the,
You have to put the operation that's before it with it. Don't forget that. Okay? Do I have any more C terms?
No.
So now I change colors and I can see I have a D term. Do I have any more D terms?
Yes.
Are there any more things I need to highlight?
No.
How many different colors do I have?
2.
Which means I should end up with 2 terms. So 20 plus 10, 30C. 8 minus 5, not negative 3, positive 3D. Now when you are combining your like terms, something that I just like to do math left or right. Okay? So make sure when you're plugging this in, you do 20 plus 10, you do 8 minus 5. That way we don't get messed up. All right. For now, we're going to skip the rest of this page and go to the third page. If you are struggling, I'm going to tell you 5, 6, 7, and 8 is great practice for you to do. Everybody got that? But we are going to practice 2 through 10. Now on 2 through 10, I see some whole numbers, positives and negatives. Do you agree? I also see some fractions, and I see some, stop freaking out. I see some freaking out happening on your face. Let me ask you, do you know how to put a fraction in your calculator? Then you can do this 100% just like you've been doing. The concept does not change with fractions or decimals. Everybody got that? The only thing that changes is instead of just writing 4 in your calculator, you would do 1 ABC 2. Does that make sense? But you do the same exact concept. You identify your like terms based on your variables, and then you go through and you do your combining. So I'm going to give you 10 minutes to work on these 9 problems. Everybody got that? You need to, there's only 9 right here. You need to highlight your like terms, the same colors. Now, everybody's colors might be different, and that's okay. All right? And then you go through and you combine. Cool? All right, 10 minutes. Go. Look at number 3. This term right here. Negative R. All right, let me give you a real life example. If I were to give you a candy bar and I said, here is 1 candy bar, am I always going to say 1 candy bar?
No.
What else could I say? Here's a candy bar. Here is your candy bar. Do you agree? But does the number ever change? I'm still giving you just 1. So anytime you don't see an actual number in front of a variable,
It is read as 1.
it is read as 1. Now, what's different about this one, though?
It's negative.
It's negative, so it would not be a positive 1R. It would be a negative 1R. So if you want to add, I know it's kind of jumbled up together, so if you want to, like, do this, that's fine. Everybody got that?
Yes, ma'am.
All right. Keep going. All right, here we go. Now, do I have some gap between all my highlight numbers, or does it all run together? I have some gaps to help me see the distinction between each of my terms. All right, then I'm going to highlight all my, let's see, constants blue. And now I'm going to highlight all my P terms green. Now, y'all probably did it question by question, and that's perfect. I just did it like this to save a little bit of time. All right. I have all my highlights. Y'all see them? Now I need to start my combining. Based on however many colors you have in each problem depends on how many terms you should have in your answer. Do you agree? So, like, which one should only have 1 term in my answer? 2, 6, 9, and 8. And 10. You're right, yeah. How many should have 2 terms in my answer? 3, 4, and 7. How many should have 3 terms? 5. You told me that based on how many different colors were in each thing. That is so important to know. Okay? So, when I start my combining, on 2, I would have done 4 plus 9 minus 11 plus 7. And what do I get?
9R.
So 9R is my final answer on this one.
Yes, I got it right.
Okay? All right. For number 3. Remember, we changed negative R to negative 1R. So negative 1 plus 8, whoops, is 7R. And then I did 6 minus 14, which is negative 8.
Yeah.
A lot of us missed this one. And I think it had to do with the negative symbols. I have seen a lot of double signs. Don't add things. Don't add negatives. Don't subtract negatives. Just take the signs that are in front of the terms. So when I plugged my red term into the calculator, I did negative 1 plus 8. Do you agree those are the coefficients on my red highlights? On my blue highlights, I did 6 minus 14. Do you see any double signs together? Don't do double signs. Okay? All right, 4. Negative 26 plus 7. Negative 19R. Negative 15 minus 7 is a minus 22P. If we're missing the math, why are we missing it? Can you tell me what's stopping us? What are we getting confused about? What? The operations?
I didn't get number 3.
You added plus signs in when you didn't need to add plus signs in?
Yeah.
Okay. Guys, take just the operations that you have in each problem. Okay? Don't add in extra operations. All right, number 5. Oh, I only have 1 red. What does that mean?
It's a 1.
You just bring it down. You don't do anything with it. You just keep it, okay? Do you see how I have 8R? I don't have any more red highlights, so I just write that one down. So then I do 12. Then what? 12 minus 3. Oh, and then I only have 1 blue highlight, too.
You have to
So what do I do?
keep it the same.
I just
keep it the same.
write exactly what that term is. Did I end up with 3 different terms? Yeah, I have an 8R, a 9P, and a negative 7. I knew that was supposed to be 3 because I had 3 different colors. All right, on 6. 10 minus 5 plus 3, and then what?
Negative.
Minus 8. What does that give you?
0.
It gives you what?
0.
Do I put 0R? If you don't have anything, I shouldn't have a variable. So it's just what? 0. Oh, if you just put R, that represents 1. Remember? If you have a variable and that's it, it represents 1. So we don't put just R. We have to put 0. There's nothing left. All right, next one. Negative 4 minus what? 15 leaves you with? Guys, you need to check this with your calculator, please. I don't want you to miss these because you're trying to do mental math and you're missing it. Everybody give me a head nod if you understand that.
Yeah.
All right, so this is negative 19P. And then I have 1 red, which means I just bring it down. On the next one, I do 3/4 plus 2 plus 1/2. And I get, anybody have that one? 3 1/4 R. On the next one, I do 1.5 minus 3 plus 8 plus 2.5, and I get 9R. And then on the last one, 2/3 plus 4/3 minus 1/3, and I get 1 2/3 P. Questions? Combining like terms. You can only combine terms that have the same what? Variable. Everybody got that? Combining like terms. You can only combine terms that have the same what?
Variable.
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 Once you identify those like terms, then you work with the coefficients of them.
Yes, ma'am.
Everybody got that? All right. Back up.